Okay. So the question says that, Salam, if VC is equal to 100 kilometers per hour, and the velocity is constant, then find the velocity of drop relative to car. Should I switch on this light? Good. Okay, find the velocity of drop relative to car. So let's do it. Okay. So all you have to do is start the solution by velocity of drop relative to car. So VD with respect to C equal to question mark. You will have VD with respect to C equal to VD minus VC. Because when someone is, okay, we still have 60 seconds. We still have 60 seconds. Yes. Okay, 10:48 is. So the question says that there is someone who is driving this car, and from that rooftop, someone has dropped a ball from a height of 6 meters. Now what happens is that as the car is moving towards the right, what will happen is that the person who is driving the car will see the ball as coming towards him as well as coming down, right? So it will be in this direction because the person is driving and the ball is falling. So you have to find the velocity of drop relative to car. That means Vd with respect to C. So I will say velocity of drop is how much? Well, that you have to find, I suppose. We will see how can we figure that out. So for now, let's write VC as VC equal to 27.1, right? Meter per second in the I direction. So velocity of drop will be, I suppose, let's say 2AS equal to VF square minus VI square. So 2A, oh come on, what happened to colors? I want to change color. What happened to paint? 2AS equal to VF square minus VI square. 2 multiplied by minus 9.81 meter per second square equal to the final velocity, I don't know, and you have dropped the ball from an initial velocity of 0. I should have told you, I think I forgot. Minus 0. What is S, by the way? 6, I forgot. So okay, I think you can correct yourself. So I think one of them needs to be white. This one. Okay. Paint. Okay. 2AS equal to S is 6 meters, and find out the I suppose distance is minus 6. Too many mistakes. So you will get a VF of 10.9 meter per second in the negative j unit vector. So I will finish the question by saying Vd with respect to C is minus 10.9 meter per second. Oh, this whole thing has really confused me. Okay, meter per second minus Vc is 27.1 meter per second in the I direction. Huh? Yes, no. So we have Vd with respect to C. So Vd with respect to C comes out to be this answer of minus 27.1 I minus 10.9 J. Does it make sense? Oh yeah, it does. Because if you see the windscreen, the person who is sitting inside his car like this will actually see the ball approaching like this. How many students agree? Let me use a nice, beautiful pink color. The Vd is velocity of drop is minus 27.1. Some huge vector like this, big, right? And then there will be a very small minus, minus 10.9 J. I apologize, sorry. Minus 10.9 J and a huge 3 times big this vector again in the negative J, I direction. So, oh, come on, I am using wrong colors. Okay, now I will put a arrow here and an arrow here. So the person who is sitting inside her car will see the ball approaching like this, right? Everyone agrees? Yes, no? Boom. So this is your Vd, velocity of ball. This is your VC. This is your VC. Oh, I apologize. I think I put the arrow direction wrong. So this is VC. I'm sorry. Velocity of car. And Vd minus Vc will be this direction. Okay. So I will put Vd with respect to C. Yes, no? Nahin? Okay. So Vd with respect to C plus Vc will give me a Vd. This plus Vc will give me a Vd. Yes, it makes sense. So this is your wind screen for students who are getting confused. This is the wind screen. And the driver who was casually driving the car will see the ball approaching like this. Done? Questions? I went a little fast because I thought it is an easy example. Should I continue? Yes, no? Stop here for 2 minutes.
Then what is the direction of Vd?
Velocity of drop? Downward. Huh? The ball is coming downward. So 1 minute. I will do like this. The velocity of car is in this direction. Okay. Right. And Vd with respect to C is equal to Vd minus Vc. So let me use this arrow. Okay, 6, 5, 4, 3, 2, 1. Questions? No. So let's do another question for you. Then I will start a small topic. Okay, where are we? Yes. I could not make the drawing because I think my notes got removed from my mobile. Okay, I really want to save some time, by the way, so you have to bear with me. What I will do is I will open one of my last semester's examples very quickly, in the hope of saving some time. So bear with me. Yeah, this one. 6, 5, 4, 3, 2, 1. So we have, let's do this example. I think it's pretty straightforward, but I have to finish the topic very quickly. We have, let's say, this chunk, right? Okay. Okay. So let's do this. Okay. And we have, okay, this is the example. Okay. The question says that we have this circular path. Now, please be careful. It's just exceptionally bad drawing that you are seeing this distorted circle. This is a nice, beautiful circle. Okay. So the car is going through this nice, beautiful circular path and it arrives at this point, right? There is a car here on this straight road. So we have two cars. One is A, the other is B. Now both of them are driving like in this direction and in this direction. You can see the directions. The accelerations, you can see the acceleration of this person B is he or she has put the foot on the accelerator and the car is accelerating in this direction. And this person has apparently put his or her foot on the brake and you can see her acceleration is in this direction. The question says that if the velocity of A is 18 meters per second and his or her acceleration is 2 meters per second square and the VB and AB are respectively these values, then you have to find VB with respect to A and AB with respect to A. Do it. These problems look straightforward to you. They are not actually. And by the way, this AA, you have to find yourself. I actually calculated for the students. You don't know this. So you can actually, you have to calculate yourself. Okay. Okay, in order to crack this problem, let me do it along with you so we can do together. The first thing is VB with respect to A. The solution methodology is rather straightforward. I will say SOLUTION VB with respect to A. So with respect to A means that I am looking at car B, right? While I am sitting in the car A. So it is VB minus VA. What is VB? Minus 12J. Very nice answer from our students, minus 12J. And minus VA is
Minus 18 cos 60 minus 18.
Good. I think everyone figured out. Minus 18 cosine 60 I minus 18 sine 60J, I suppose. Right? Let me double check. So B with respect to A comes out to be 9I plus 3.6J, right? Please do not be dependent on the way I am writing the answers. You have to double check. Okay, good. Now we will go for the physical realistic interpretation of results at the end. For now, let us, you are following me, right? Sure. Okay. What about the last part of the problem? That is A, B with respect to A. We know the formula. It is AB minus AA, correct? Okay. For AB, you have to be careful. First of all, it's a horrible circle that I made. It's a beautiful circular path. It is right at the end of that circle. No, not at the end of that circle. Yeah, probably, because if that's the circle, then it will become into that road. So that person is sitting right at the edge of that circle. So he or she is still at a circular path point. This means he or she will have two components, right? So there will be a tangential. Good. Tangential. Yes. Good. You said radial component. That's fine. Tangential and normal I will use here, but you are also right. A B T plus A B N minus A. Oh, come on. Now the figure disappears. So what should I do? I will hang in there with me, please, everyone. I will just do a control C. Actually, anyways, so let us do this. Okay, now I will say, along with you, I will get hold of that other software soon. Okay, A, B, with respect to A, everyone agrees with me, A, B, T plus A, B, N minus A. Then A, B, T is minus, yeah, value I forgot. It is
1.2
minus 3J, huh? Minus 3J, because it's in this direction, the acceleration given, plus now the normal acceleration is pointed towards the center of curvature. So one of the students told us negative I will agree with him. So it is V B square over rho I. This time I will do a control Z and I will put minus VB square divided by 100. What is velocity of VB? 12. Okay, 12. Then I will put I unit vector and then minus. The acceleration, you can see the green arrow. So this fellow has put brake. So I will put bracket. So whatever the value is given, I think the value given was 2. Thank you. So I will say 2 cosine 60I plus 2 sine 60J. Now please remember, I am going at sonic speeds. So if any student is just not following, you have to stop me. So I will say A, B with respect to A gives me a nice answer of, you do it, I don't know, whatever the answer is. Oh, I don't have it, by the way, in my notes. That's not good. Okay, so VA is 18. There are students who don't remember these values. I will write it for you. 2 meter per second square, meter per second. VB is 12 meter per second. Please hang in there with me. And AB is 3. Are you sure? I'm just cruising through it because I thought that it is here. Okay.
Minus 2.14 minus 4.736.
Minus 2 point
44 or
I
minus 4.736.
minus 4.732. Okay, that's a nice answer. Okay, now last but not least, please remember this purple arrow, I did it in the solution. So VB with respect to A came out to be 9I plus 3.7 plus 3.6J, right? So you can see that with respect to A, so that's why I went to the car A and I plotted 9i plus 3.6j. This looks like 9, this looks like 3.6. So this is VB with respect to A. I created this purple arrow in the solution. Of course, this is not given. I did in the solution in front of the class. Nobody is asking any questions. Is it clear? Sure. Anyone? Any student? No? Sure? Positive? Hello? Okay, well, students are not asking any questions. So, similarly, you can also make a beautiful vector of AB with respect to A. You will do it yourself. Yeah. So go to the car A, put a negative 2.44 here and put a negative 4.732 in that direction and create an arrow. That will be your AB with respect to A. Just to be clear, why is my purple arrow in this direction? Well, as the person is going in this direction, by in this direction, I mean this direction, and the car is going in this direction, you can see that the velocity of car B, I suppose, is less, and the velocity of car A is 18. So since the car A has a higher velocity, this car appears to be coming towards this car in this particular direction. Okay, left and right, but I think we have finished this question. Okay. Okay, well, let's talk about constrained motion. Now, all these objects, they are not connected with ropes. The car A is separate, the car B is separate. We are looking at the other car. They are completely independent of each other. But what happens if we connect the objects with a rope? Well, that's what is known as constrained relative motion, which is our next topic. Constrained relative motion. So let's do this. I will talk about few rules. Number one rule is reference line. So you come across such kind of a pulley kind of a mechanism. The first thing is reference line. You create a reference line, the problem will be done. So the questions would say that if the object B is going downward, let's say, at a particular velocity, let's say some particular value, 3 meters per second or whatever, then what will be the velocity of object A? Similarly, the question can say if the object B is accelerating like this, let's say, or accelerating downward with a particular acceleration, let's say 2 meters per second square, then what will be the acceleration of this object? So this will be how these questions will be put to, will be formulated, that you have to find the velocity and acceleration of the other object that is connected with a rope or a wire. Okay. So the number thing that you will do in the solution is you will have to create what is known as a reference line. Please follow me. Now, there are different reference lines that all of you can make. Some student will make the reference line on the top. Another one can make at the bottom. There will be another student who can make the reference line between the two masses. There will be another student who can put the reference line on the moving object. Okay, now please remember, at least for this class, remember that the reference line would be put on a stationary object or stationary thing. Number one. Number two, the reference line will be on one side of the objects. It will not be between the two objects. So let's make a reference line following these rules. Number one, not on the moving object. So do not put on A or B. Number one. Number two, don't put the reference line between the two objects. Put on one side. So let's say I am putting my reference line How many students agree here? Done. Second thing that you will do is you will, let's say this is the radius. So I think I should have been more specific. This is the radius of the pulley. Okay. Now, the next thing you will do is you will start naming them. So let's say this is your XA. Please bear with me. XA. It starts from here, goes all the way up to here. Done? These things you have to do yourself. XA. I hope it is visible to our students. No? The next one will be XB. Oh, come on. Okay, this time around I will make it big. Big font. Okay, done. XB, done. Now you can also name them as, let's say, height B2 if you want, or probably 50% of this is you can name it as B2, and 50% of this fellow you can name it as B1. Okay. Is this even visible to our students? Okay. Similarly, you can call this as your height H. Now, I keep on emphasizing that this whole hard work has to be done by you. You are the one who is defining these dimensions, okay? Till the rigid, huh?
Till center of pulley.
Yes, till the center of the pulley. Okay. Now you have to count the number of ropes. So how many ropes are in this problem? One, huh? In a homework assignment, I will give you a complicated problem in which you can see 2 or 3 separate pieces of rope. At least for our examples, I will be following one rope. So length of the rope is equal to, count with me, XA minus H. Count with me, XA minus H. You arrive here, huh? Follow me. Plus you will go here. Plus we have student who said pi r. I will say 2 pi r over 2. Okay. Then you will arrive here. Okay, hang on with me, please. Okay, we arrive here, then we do 2 pi r divided by 2. Then I will add this chunk. Okay. So I will say plus 2 pi r over 2 plus xb. But the problem is that xb minus h I have to do. So please stop me if it's confusing. XA plus XB plus pi r minus 2h. Agreed? Minus 2h.
Why you draw 2pr divided by 2?
Because look, where is your rope? Rope, rope, rope, rope, rope, rope, then rope, then rope, then rope, then rope. So I went from here to here, which is my XA minus H. Then the rope goes from here to here. The complete circle is 2 pi r, but the rope is 50%. So 2 pi r divided by 2. Then I went from here to here. Oh, okay. Good. Okay, students agree. Then dl by dt. Rope length is not changing. Okay, do it. Give me the time derivative equated to 0. Give me the velocity of the object A in terms of velocity of object B, acceleration of object A in terms of acceleration of object B.
Why you said velocity is 0? Because the system is not moving.
No. The length of the rope is not changing.
So there is in the mind it is steady, right?
Yeah, good.
It is said right because there the L over dt is equal to 0.
Length of the rope is not changing.
Yeah.
The length is the length of the rope. So dl by length of the
No,
rope.
time is
can-
not changing.
Huh?
VA plus VB.
Yes. Plus V. Because pi r is not changing, and also
Which formula?
if we
Or
take the,
velocity.
if you take the dielectric,
Yes, that's what I'm saying. The length of the rope is not changing. So dl by dt is 0. The rope is the rope's length remains constant.
therefore the velocity of A equals the velocity of B.
Okay, I will finish this. I did not understand. So you will say dl by dt is equal to 0 VA plus VB plus 0 minus 0. So VA equal to negative VB and AA equal to another time derivative AB. Makes sense, right? As this goes up, this goes down. So the velocity of A equal to negative of velocity B. Now, hang on with me. So let's say if the velocity of VA equal to 2 meters per second upward, then VB equal to 2 meters per second downward. And similarly, if AA is 0.5 meter per second, 0.5 meter per second square upward, then AB is 0.5 meter per second square downward. Everyone understands this? Okay, now let me tell you something. It seems very easy, right? If I remove the reference line, I remove everything and I give you the problem, it is not as easy as you are thinking. In the last semester, I don't think I even gave any pulley problem in the whole semester, but this time you have a lot of time in your midterms, 2 hours, and final is 3 hours. So probably I can give you a pulley problem, but remember that these problems are not easy as you are thinking. Okay. Do we have any questions in this?
Yeah, how about if the rope was in compression?
You mean elastic?
Yeah, right now they are taking the mass B and pulling it downwards. If you were to push it upwards, then the mass A wouldn't be affected and the change of the length wouldn't going to be 0.
Oh, you mean like this?
Yeah.
No, but because we are intentionally taking a rope, right? So that's why. Oh, yeah. So you can actually pull this thing downward, so it will go upward. But what do you mean by the length of the rope is changing?
For example, if you go to, for example, in that situation, the mass B, you hold the mass B, instead of putting it down, you push it up. So what happens is that rope, so it changes, so we cannot say.
No, I will tell you something. Instead of pushing B upward, you think like this. You pull A down.
Yeah.
Yes.
When we find the acceleration, we can find the force acting on B and A, right?
Oh yeah,
If
but
you want to find the
that we will do
kinetic-
after 3 weeks. That we will do after 2 weeks. Like I will finish kinematics probably next week. Then we will start kinetics. 50% of the semester is about forces. You are absolutely right. This is exactly what we will be doing. It is even available on last semester's Google Drive. Okay, do this problem then. There are students who want me to do another example. Oh, come on, do this. Now, again, I have made the problem easy for you. Trust me, it's not an easy problem. I am the one who created these XAs, XBs. That's why it will seem easy to you. But again, you have to come up with the reference line. What are the rules? Number one, reference line should be towards, it should not be between the two masses. So for example, it is very tempting that a student puts a reference line here. This is stationary, right? It is very tempting that you put, but again, you can come up with the right answers, but it will become a little confusing. I don't want to get into that. So put a reference line on a stationary frame of reference in either way, in the either direction of the two masses. So I put it extreme to the left and I used XA. Now there are students who are saying, should we make XA to the center or till here or till here? It depends entirely upon you. I am making in this problem at the end of the A. So that's fine. For all of them, the X I am defining till the end of the mass. Okay, how many ropes? One rope. How this pulley behaves? The rope goes, it is attached to the center of this one, goes all the way from this pulley, goes around this pulley, gets attached to this one. Are you following me? Now, if you pull this mass towards the right, you can see that this mass will also move. Now, you can see this brown rigid rod that I have created. Just to tell you that this is a rigid rod. This is not a rope. So you pull this. Just to be clear, this thing is stationary. Okay. Okay. Do this problem.
And we just say that the A is equal to 1/4 of the.
You already calculated.
No, it's obvious. You don't need to make it complicated.
Actually, your answer is pretty close.
Not right?
No, it's 1/3 actually. Not
We just
1/4.
count the ropes.
Huh?
So we just count the ropes?
Yes, we can, but the problem is the length of the ropes are different. So your answer is very close. I said, yes, we can count the ropes. I said 1/3. What did you say?
1/4.
1/4. No, 1/3. Good, very good. His answer is correct, but is nearly correct. So let's do it together. We will say length in the solution equal to solution is L equal to, okay, let's count the length. It is XB minus XA, right? So this is XB, this is XA. So right now I'm talking about this rope, okay? Everyone, are you following me? Now there are students who are saying that XB minus XA is not the length of the rope. There is this rod as well, right? So I will put a plus C. I'm not going to bother about the length of the rod. It's a constant. Then I will count the second rope, this one. So it is XB, XC minus XA, correct? How many agree? What is XC? Let's say this is my XC. Now there are students who are saying that XC minus XA does not give you the length of the rope. You are completely wrong, because the rope is till here and there is this rigid rod, and then they are saying that there is this fellow as well. Yeah, but that is a constant, right? So I will say that I will not be worried, and I will say XC minus XA plus a constant. And then I will calculate the length of this rope, and I will use the same strategy, plus XC minus XA, and I will not be bothered about the little constants. I will put them as positive C. You can say it's negative C, it's a constant. That's why I said your answer is so right, because now if you take dl over dt equal to 0, you will see it comes out to be x dot b minus x dot a plus
So why are we not adding 2 pi r over 2 in this case?
1 minute. I will answer your question, please. So, so did I make a mistake?
It's not, there's no mistake.
What about XC?
XC doesn't change.
It's a constant, right?
Yeah. So
Good, thank you. Thank you, very good. I appreciate it. Good. Thanks. So he's right, plus 0 plus, as he rightly pointed out, XC does not change. So 0 minus X dot A. I will answer Abdullah's question in 1 second. I remember you asked me a question. Plus 0 plus X dot C minus, okay, X dot C 0 minus X dot A plus 0. So we will get equal to 0. So the answer comes out to be X dot B equal to 3 times X dot A, and take a time derivative. VB equal to 3 VA. So write it as VB equal to 3 VA and AB equal to 3 VA. Take another time derivative. Sorry. 3 VA. Okay, you asked me this question, right? What is your question?
I was saying, why are we not taking the radius of the pulley?
Because that section
Coming is
that section does not change. So for example, look, the rope goes around the pulley, right? That section of the rope will be 2 pi r divided by 2. So r is the radius of the pulley. So that does not change. Rope always, that chunk remains as it is. So you take the time derivative of a radius of something that is not changing, that would just vanish, disappear.
Yes.
Are you with me? Everyone? Do you want me to?
What's C stand for? I don't understand.
Constant
What's the length?
of the constant?
Yeah. Like which part is C?
Okay, I will explain. I just skipped it. I thought that, okay. XB minus XA. Look, this is your XA, this is your XB. So XB minus XA is this one, correct?
Yes.
You see this distance, this is a constant, C1. Similarly, you see this chunk, the rigid rod, that's a constant. So when you're talking about the length of the rope, I have to subtract this chunk. In fact, I have to subtract, let's say, this chunk, and then I have to add this little portion of the rope. Are you following me? C2, this little chunk of the rope is a constant because radius of the circle is constant, C3. So C1, C2, C3, they add or subtract to give me a constant that does not change. So that's why I am not bothering to get into the dimensions of these. Is this clear? I just cruised through it because I thought that it is.
Sir, although it does not make any difference, but can I say XB minus XA minus C? Because XB minus XA, let's say, give us the length.
You mean the constant?
Yeah,
Oh, good.
constant should be minus.
Good. But negative constant is also a
Yeah,
constant.
it doesn't make any difference. But makes the approach more realistic.
Yes, do the negative. See, I have no issues. Okay, so the question says, if velocity of VB is 3 meters per second and acceleration of 1.5 meter per second square in the same direction, find VA and AA. Can you do it? Do it. 1/3 of it, right? Okay.
VA is 1 and AA is 5.
0.5. Okay. So I will take his answer. He said it is VA is 1. In which direction? Same direction, right? When you pull this object to the right, this object also goes to the right. That's why your answer is coming out to be positive. Now, I don't want to confuse you, but the only reason I keep on telling you, don't put the reference line between the two masses. If you put the reference line between the two masses somewhere, then I think positive answer will mean they are moving towards the reference line. And a negative answer, I think, would mean that they are going away from the reference line. It becomes very confusing. That's why I keep on saying, use the reference line on that end or that end. So to both the masses or all the masses should be on one side. Okay. Should we continue? Okay. Any questions? Please stop me if something is not clear. No? Positive? Really? Do this problem yourself then. Okay, again, I think I picked the reference line. That's not good. But this XB and XA, you have to define yourself. This is your mass B. This is your mass A. Count the number of ropes. There is one rope. So these are easy problems. Okay. Anyone who intuitively can guess?
Opposite side.
Yes, very good. Very nice. It's very hard for me to intuitively come up with the answer so quickly, but anyways, nice. So, 1 minute. Solution is L equal to, anyone who figured it out? Huh?
XA equals 2x, XA plus 2x.
Good. Very nice. So XA plus XB, I suppose, minus HB plus XB minus HB minus HA. So L dot will be X dot A plus X dot B minus plus X dot B, and you can put 0, 0, 0. L dot equal to 0. It will give you X dot A plus 2 X dot B, and X dot B equal to let's say, or X dot A for that matter, whatever, equal to negative of 2 X dot B. When the mass B, let's say, goes downward, then mass A goes upward and mass A will have half of the velocity. That's cool.
John, are you taking the derivative of L with respect to X?
You have to repeat the question, please.
Are you taking the derivative of L with respect to X?
No, with respect to time.
And,
The dot means time.
I know, but with the X already.
Yeah, dx over dt. So for example, this is dl over dt, dx over dt, dxb over dt, dxb over dt, dh over dt. I am taking the time derivative.
But, you took the H ones or over the T as zero.
Yeah, so height of the this length of the rigid rod, it does not change with time.
Okay.
And similarly, the length of the rope, it does not change with time. That's why dl over dt is 0. dh over dt, the length of this rigid rod with time does not change. Yes. Okay.
Could you explain the L part again?
Yeah, the length of the rope is not changing with time. So for example, when you started the mechanism, this is the length of the rope, right? The length of the rope does not change. After 20 seconds, 2 hours, 10 hours, the length of the rope will remain changed. This can come down. This can, for example, this mass can come down. This can go up. They can do whatever they want, but the length of the rope will not change.
So how mass B will move? Because isn't it connected from the center directly?
The mass B,
Yes.
this pulley, for example, if this fellow goes down, okay, then this pulley will go up, then this mass B will go up. Okay, this is a rigid, this wire is rigid, by the way. This is not rope, this line. The rope is blue one. Okay. Okay, everyone. On that note, I will finish the question and I will say B A equal to -2 BB and AA equal to -2 AB. Okay. Please bear with me, everyone. 6, 5, 4, 3, 2, 1. Okay. We are not talking about these problems in which the rope is like slanting like this. We are talking about straight ones. Okay. Okay, do this problem quickly. Again, the reference line should be on some stationary place at one side of the masses. I drew the reference line for this problem here. Students can disagree with me. They can say that we want to make reference line here. That's fine. Okay, intuitively, if anyone guessed it. Anyone? 1/3? Good. 1/3? Okay. Very nice. Length equal to? Do it. Give me the length quickly. Give me the length. Your name is Ghazal, right? Good. Bahadur, give me the length. Ahmed, give me the length. Length of the rope will be. Length of the rope. Okay, so again, this is one rope. In your homework problem, I will give you a complicated one. XA plus XC plus XC minus H plus XC minus H, right? Follow me. XA plus XC plus XC minus H plus XC minus H. Okay. So L equal to dl over dt equal to 0, and it gives me x dot a plus 3x dot c equal to 0, and we get VA equal to -3 VC and AA equal to -3 AC. Boom. This is your mass C. This is your mass A. Okay. So far, so good.
15 minutes.
15 minutes, you know. He said 15 minutes.
How you think these problems are understandable, but I think they are pretty simple.
Yeah, that's what I'm realizing in front of all of you, because many students are just intuitively saying, I thought these are challenging, by the way. No? Okay, so we can go on a break, but there is this take-home problem as well, right? So we can go on a break, but I will give you a take-home problem. This one. Isn't this challenging, by the way? I think it is, no? Okay. 1 minute. How many rope? One rope. But you can see that now the question says that I suppose the rope is actually getting into that motor, right? That fellow is wrapping that rope. So that whole thing is rotating at 47.6 radians per second. I will double check the units, but I think it's radians per second. So how will you do it? It is tricky. So now I suppose the dl over dt will have a value, non-zero value, because there is a certain velocity with which the rope is being pulled into that thing. Right? You can do a v equal to r omega. Are you even following me? Huh? V equal to r omega. No, that whole thing is wrapping the rope.
Right.
So if this thing is rotating and it has a certain radius to it, the rope is being wrapped around it at r omega, v equal to r omega. So if you have the velocity, let's say at this point, then you can think about this problem and solve it. So this is your take-home problem. Okay, good. I will try to find a solution and I will post the solution. And trust me, for more ropes, more than one, these become challenging. We can have a 5-minute break. Let's meet at 11:41.
But 10 minutes.
This is all convenient.
No. So, okay. Do you want 5-minute break or 10-minute break? Oh, come on. Seriously?
Yes.
I thought that it's a pretty
It's
interesting.
all right.
No?
What's wrong? Hocam, you said, I knew it's break.
Okay, 10 minutes. Okay. Okay, 10 minutes break.
Tamam, zamanla göre köye aldığınız zaman. Zaten sabit olduğu için zamanla göre.
Şöyle bir x eksi h.
Aşağıda zaten zamanla göre değişiklik göstermeyecek. Yani delta, yani L'yi zaten bulduk değil mi? L'yi bulduk. L hem fonksiyonlarla hem de sabitlerle olan bir şey.
Ben siz demek istedim. Ben siz demek istediğim anlamda şu vektörleri yazacak. Nasıl böyle?
Yani
Artı 2 pi ve bölü 2. Ondan sonra şöyle geldi. Sonra artı 2 pi ve bölü 2'den geldi. Sonra yukarı çıktı. X ve x'i kaç ve değil mi?
Evet.
X ve x'i kaç ve artı 2 pi eksi 2 başlıyor. Tamam. Şimdi ben de not alırsam x a değişecek. Aşağı gitti. Artı 0. Artı 0 buraya gitti. Artı 2 x b. Aşağıya da gitti. Artı 0. Bu mu?
Aynen. İki ayrı var. İki şuradan zaten bir çıkar. Sonra daha önce red bir sonra vardı ya. Burada ben onu yazamadım daha. Hangisi? Yok, hangisi yok göstereyim. Nasıl yazdı şu sayfa?
Önceki şu mu yani?
Yok, onu yazdım. Bunlar bu combo şey combo vermeden önceki en son
Nasıl yaptın? Bir sayısının bir ikisini bölüyorsa o zaman.
Okay.
Şimdi soracağım sana. Kısım fotoğrafını çeksen ben onu olur.
Nereye istiyorsun?
Kanka bu
İstediğiniz yazdığımız KBC artı
yok.
Okay.
Şu. Aynen bak.
böyle yazınca daha şey geldi. Yanında yazamıyorum ama.
Hepsini açıklayarak yazınca da çıkıyor işte. Kafadan görüyorsun.
Ya ben sadece şunu soracağım. X ve X'e H ve X ve X'e H ve. Pireleri o yüzden aslında bir aslında şuradan iki tane geçtiği için iki tane H ve X yazdı. X ve'miz normal zaten. Bir tane de X'e eksi H'a diye yazdı. Tamam.
Okay. Okay. Okay. Oh, yeah.
Do you have the answer for the?
No. Unfortunately, I don't, but I will see your solution. I don't have the answer, but I will find the answer or I will solve it myself. Okay.
Yeah.
Okay. $35, $45. Okay, I think we can start. So the problem is somewhat like this. Again, I will finish it very quickly. I think you understand unconstrained motion now. Very quickly, this is a aircraft or whatever going in a straight path. This other fellow is going in a circular fashion. The velocity and acceleration of this fellow is given. The velocity of this fellow is given 600 kilometers per hour in that direction, of course. And the acceleration is in this direction. Now this fellow is going in a circular path and the radius of curvature is given to us as 400 kilometer. This 4 kilometer, honestly, I am not sure. Probably it's the distance between this fellow and this fellow, but I don't think it really matters. So let's not be worried about this 4 kilometer that is given to us. The question says that you have to find the velocity of this fellow with respect to A. So let's say I am sitting in here and I have to see how I perceive. I apologize. I am sitting in A and I want to see how I perceive the motion of the aircraft B. So VB with respect to A. Okay, you already did it. Okay, done. Okay, good. I understand. So let me just write down the answers. I think it's pretty clear at this point to all the class. VB with respect to A equal to VB minus VA, which is equal to 600 kilometer per hour J minus VA is you said 700, right? Kilometer per hour J. I think in per hour you don't have R, right? You can just double check these little things. Or perhaps there is, I don't know. And last but not least, you have A, B with respect to A, and that is AB minus AA. Please remember that velocity is very intuitive to know, but accelerations are difficult. Now, AB is, it has two components. One component is this one, negative 100 J, right? But it is in circular path. So there will be one component of it towards the center of curvature. That is towards the positive I. So 600 square divided by V square over rho. So in the I direction, minus AA is in 50 kilometer per hour square in this direction. So minus 50 J. Now all of these are in kilometer per hour square, and your final answer comes out to be 900I minus 150J. What are the units? Kilometer per hour square. I really went at sonic speeds. Is this clear or not? No? Look. Hang on. I think they responded with that We are not even done finishing the questionnaire. So this aircraft is going in a straight path. This is going in a circular path. The question says that I am sitting inside A. How do I perceive the motion of B? Okay. So VB with respect to A, that is VB minus VA. The velocity of A is 700 km/h in that direction. The velocity of B is in that direction. So I did a 600 by 7 the J. For the acceleration, this guy is in the circular path. So it will have two components. One, the acceleration in the tangential direction, negative 100 J, and one towards the center of curvature with a V square over rho. And then I subtracted that one. Okay. Yes. Okay. 5, 4, 3, 2, 1. Life is beautiful. Let's start. Sorry. Now, let's start the kinetics. I think I ended up telling you that after 2 weeks we will start. I was wrong. We were about to start the kinetics today. Now, there is a introduction that I can give you, the type of forces, there are ropes, all of those things. But I think as this course progresses, you will get to know those details. Let's tackle a very simple problem. Kinetics. You can do that problem later, no? I think we can all focus on here. Anyways, kinetics means we talk about forces. Okay, till now you had been talking about kinematics, velocity, acceleration. From here onwards, you will talk about kinetics. Okay, so let me tackle a simple problem. Okay. Look, I have a very simple way of telling you this. You know how to find the accelerations, right? Of course, this is what you have been doing. If you know the acceleration, then you also know F equal to ma. So if you have the acceleration of an object, how that piston is accelerating, you can also talk about what kind of forces that piston is subjected to. So you have gone through the hard bit. This is should be relatively easy for you. The first part will be the kinetics of point mass objects. That is, you have a big car. We don't care that there are 4 people sitting in there. It has 4 different tires. There is a bumper. There is a dashboard. We don't care about that. We will say that this whole thing is one big box chunk. That is point mass. And in the later part, we will talk about kinetics of rigid bodies. There is 2 guys sitting there. There is 2 people sitting in the back. There are 4 tires. There is a bumper. So point mass. The question says that you have this 60 kilograms. The question says that you have a force acting in this direction, 300 newtons. The question says that this angle is 30 degrees. You have to give me the acceleration of this fellow. Okay. The coordinate system, yes. I will update you. Give me a second. His question is friction. Very good. Nice question. Mu K equal to 0.3. Coefficient of kinetic friction. Kinetic friction. G equal to? G equal to 9.81. 9.81 meter per second square. Okay. How do you do it? Good.
we found the friction, and then we found the net force on the x-axis.
Very good. Number one, Newton's law. Solution SOLUTION. Summation of forces equal to mass multiplied by vector. Correct? Right? Then you have summation of forces in the y direction equal to MAY, where AY is 0. And then you will say summation of forces in the x direction equal to MAX, which is our today's question. Yes, because the object is not leaving the surface. Yes, good. So now what you will do? You will say summation of forces in the y direction. Number one, you will make a free body diagram that was taught to me in my physics 1, right? Now, hang on. Why is this not a rigid body kinetics problem? If it had been a rigid body kinetics problem, just imagine if this was 10 meter tall and 1 meter wide. What would happen? Topple, good, topple. 10 meter tall, 10 centimeter, it will topple. So in rigid body kinetics, I have to give you the dimensions of this box. Right now, we can't care less. For us, it's just a little lump chunk that we are moving. Its dimensions are not important to you. That's why this is very easy for you. Point mass kinetics. So easy. Okay, so we will do a, come on, this one will be one arrow. What is the name of this arrow? Normal force. Then there will be another arrow. This will be our weight. So this is the normal force. This is the weight. Now, normal force acts 90 degrees to the plane of contact. So I saw this and I put a vector up. Okay. Then I will say there is a friction force acting. How can I ignore this? And unfortunately, I need to be sure that it's right through the center. Okay. What is the friction acting in this direction? Boom. I call it as small f. Now, please remember, in an exam setting, although you don't do that, but if you want to use a different color, you can use a different color and you can put A here. Although we make a separate diagram called a kinetics diagram, in which we talk about the accelerations and all that stuff. But if you use a different color, I have no issues. So we will say positive N minus mg equal to.
So what about the applied force? You have applied force.
Oh, did I forget? Okay, thank you. Very nice. Good remark from one of the students. What about because in a free body diagram, you have all the external forces and reactions. That was a nice comment from our student. Okay, so N minus mg equal to, I apologize, N minus mg minus 300 sine 30 equal to 0. Okay. N minus mg minus 300 sine 30 equal to 0. So normal force comes out to be, I don't know, you give me the value. Then summation of forces is equal to max. Friction is acting towards the left. The applied force is acting towards the right. You can see the coordinate axis equal to mx double dot. What is the value of friction force? Anyone? Normal force time the coefficient of friction plus 300 cos 30 ma subscript x. So I suppose there is no harm in putting this as ax. This value. Okay, the value of n is in newtons. I'm not doing it. You give me the value. And ax comes out to be, boom, meter per second square. Done.
Right, and yes,
Who is joining us? Yeah, what did you tell me? Okay, good. What about the acceleration?
0.63.
Impressed, very good. Both of you were very quick in the answers. And normal force is 300? 738. Double check. Anyone double check and then tell me. Everyone. At least 2-3 students.
Yeah, it's 738.6.
6. Okay. Okay. Abu, you can hear us, right? Abu, you can hear us? No? Okay, we have started the point mass kinetics, as you can see. Should I continue? So free body diagram, I showed you a free body diagram, how to make. No questions? Positive? Okay, then let's do another problem. The question says that you have, let's say, and then you have a nice and beautiful fellow like this. This is again rollers, whatever. The object has okay. And then you have a collar, very beautiful here. By the way, this is going to be one tricky problem. The collar can slide, I suppose. Oh, come on. Okay. This angle is 30 degree. The question says that find x double dot for which the collar stays, for which the collar stays at the location without moving upward or downward.
what is the mass of the?
Yeah, I think I have to give you the values. That's what I am thinking. No, mass is not given. That's not good. Nothing is given. Yeah, I think the mass will cancel, no? That's not good.
Mass of the inside object and the mass of the color isn't the same, but the acceleration of the color is equal to the acceleration of the inside
Yes.
object.
And that's the red line of
Okay, Ahmed, I have to think about it. Okay, let's go step by step. Probably we will all figure it out together. The free body diagram. Let me make a coordinate axis. Huh? Yes or no? Okay. Let's make a free body diagram of the collar. So the collar will be like this. How many agree? Okay. What will be the direction of the normal force? It will be in this direction, right? 90° to the contact. Agreed? Okay. What will be the direction of the collar's weight? Downward. Okay. Weight. Okay. Then what will be this angle? It will be 60, I suppose. Not sure how many agree. Good. Okay. What will be this angle will be 30, I suppose. Y-axis, I think, and this is my x-axis. So I will try to answer his question. Summation of forces in the x direction is mx double dot for this collar, right? And we will get n cosine 60 equal to mx double dot. Let me call this as my question 1. And then summation of forces in the y direction. You do it. What will be the summation of forces in the y direction?
And cos. First.
Huh? Everyone did it? Okay. And cos 30 minus weight 0, right? Okay, it's because
So it's equal to, no, yeah. I get it.
oh really? Yeah, okay, yes. I think the whole cart, and then there is a collar on that cart. So when we say summation of forces in the x direction is equal to mx double dot, that x double dot is for the cart as well as for the collar, I suppose. Whereas when we talk about summation of forces in the y direction, that is equal to 0 because even the cart is not going up and down. So
And also the question says location without moving upward and downward. The reason we say 0 is
for upward and
comes
downward.
from that statement, right?
This one. This 0 comes from that statement. But this comes because of the fact that the cart is moving. Okay, nice and beautiful. So we get cosine 60 over cosine 30, correct? Equal to minus x double dot over g. So I suppose the x double dot comes out to be
Minus 1 over square root of 3 times 9.8.
yes, you're right.
5.6.
I think I made a mistake. Will I get a negative? Hang on. Positive, nahi? I think so. Cos 60%. Okay. So x double dot is
5.6.
5.7 meter per second. Nice and beautiful.
Hocam,
Huh.
is there friction between collar and the roll?
No.
Frictions, right? Because of that,
Wait, do we have friction, by the way?
we don't put
We
friction.
don't, right? No, because if I do n cosine 60, no, because if I'm doing n cosine 60 equal to mx double dot, and if there had been friction along the rod, then I would have to calculate that friction, and then I will have to make a projection of that as well, right? Agreed? No friction, I suppose.
Sure, can I ask something?
100% yes.
Why is there no acceleration in the y direction?
Because the whole cart is not going up or down, right? The cart
No,
is
for,
just
for the
moving.
color, for the color.
Uh,
Because the color is moving downwards or upwards.
no, it's not. No, collar is not going up and down. That's what it says, without
That's
moving.
why, okay, that's why we don't have a wide angle.
We don't. But in fact, we also, the collar only has an X double dot because it is sitting on the card that is going in that direction. The whole thing is going in that, in X double dot. Okay, we still have time, by the way. Wow. Okay. So. Three. Let me do another problem for you then. Okay. Please bear with me. Let me. Okay. Okay, here comes the question. Oh, what happened? Okay. Yes, we had a question. Oh, yes, I started the recording. And we had a question from here, right?
In the last problem,
Huh?
like the opposing force will be caused by air, I think.
Huh? No.
Air resistance, right?
No. We never talked about that.
So what's the reason?
What's the reason behind it?
Yeah, the opposing force.
Oh, so for example, when
Like the card is moving, so that I don't know, that box is not slipping down, right?
because
What's the reason behind it?
because somebody's if you push somebody, that feeling, is you immediately push. How should I explain? So for example, when we have a glass of water, you suddenly accelerate, then that level of water goes like this. You stop the level of water. That's acceleration, right? So you're not getting my point. So if you the cart is accelerating, the collar wants to stay there, because otherwise, if you make it stationary, the collar wants to go down.
So it's not air.
Of course not. No. So we have a collar. You are accelerating. You're pushing it. So the collar also it wants to stay there. Huh? Okay, everyone. Life is beautiful, I guess. Let's start the problem. Hang in there with me, please. Let me take a picture of my notes. Okay. Okay, do this problem then. Got it? Answer? Oh, you got it. That was quick. So, how to do this problem? When we have to do this problem, find the maximum acceleration that is allowed when applying the brake before which the box tends to slide or move. Find the maximum acceleration that is allowed when applying the brake before which the box. So the point is that I'm going on this truck and I have some sensitive equipment back there. If I really push the brake, like boom, what will happen is that the whole equipment wants to move. I don't want that, right? So I really want to apply the brakes gently. So solution, I have to find the maximum acceleration that can be subjected to this cart. Number one, you define your frame of reference. The question is clear? Positive? Okay. Okay, number one, let's make the free body diagram. Okay, you have a question? No, yes, okay. Then we have, this is the normal force perpendicular to the, what happened? Okay. And we have the weight acting in this direction. What about the friction?
Towards left.
Okay, that's nice. Friction is, if this box wants to slide towards right, the friction will be acting towards left. I think we should use the same colors, by the way, but I am using different for now. Then we have, please bear with me. X double dot definitely in a different color. In a free body diagram, usually we don't put the acceleration. So summation of forces in the X direction equal to mx double dot. And the summation of forces in the Y direction equal to my double dot. I am not doing this question, you are doing it. Do it. Huh?
Also, question can be like, what is the allowable
Yes.
acceleration?
Huh.
For example, if car
Got it.
go fast,
Hmm.
the box will be go back.
Yes, 100%. So I suppose the same answer will come out for that one as well, that the guy is going at 70 kilometers per hour and he really puts the foot on the accelerator quickly. The box wants to slide back. The same logic. No? Yes. The car is going towards right at 70 kilometers per hour. And at a certain point, the driver puts foot on the brake. No. Oh. No. I will tell you. No. The question says applying the brake. So at 70 kilometers per hour, the person puts the foot on the brake. So the box wants to go forward, right? So suddenly you put the brake. So that's why the friction will be backward. That is static friction because the box is just sitting here and it will move. If, for example, the box had already been sliding, that would have been a new gauge. That is coefficient of kinetic friction. No, because no, look, what is look, if this wants to slide like this, friction will be backward direction. So when you put the foot on the brake, the cart wants to move forward, right? And that's why the brake is, that's why the friction is backward. Look, it's on the back side of the car. Suddenly I put my foot on the brake. So this water bottle wants to slide forward. So the friction will be backward. Okay, I think our students got this.
We don't know M1.
Huh?
We don't know hocam.
No, probably I forgot. Do we need it? Either I forgot or we don't need it. I think we don't need it. Let's do it together. So we have summation of forces in the X direction minus n mu s equal to mx double dot. For the Y direction, it is positive n minus mg equal to 0. Because this whole thing is not going in the Y direction. So I will call this as my equation 1, 2, 3, 4. And n comes out to be equal to mg. So I get a very nice, what happened? So we get minus mg. We have a student who asked a question. What happened? Okay, minus mg mu s equal to mx double dot, and I get x double dot equal to minus mu s g. By the way, the whole class understands the difference between mu k and mu s, right? The mu k is when the object is already in motion and you have friction, and mu s is when the object is stationary.
And maximum value, right?
Mu s is exactly.
When it's just about to move.
When it's just about to move. Nice, thank you. Okay, so x double dot comes out to be
Minus 2.9.
minus 2.94. Our student has given us the answer. Thank you. Very good.
So therefore, the box will be moved like this, but it will be decelerating towards the positive x direction, right?
No. Oh yeah. Oh, no. So x double dot negative 2.94 means that the person who is driving a truck, if he puts the foot on the brake and gives a deceleration of 2.94, the box will move.
What is y double dot means?
Acceleration in the y direction.
But the box is not moving in y direction.
That's why I put a 0, no? Did I? I did not?
Yes, we could say there.
No, I think he's right because I should have. Look. 0. No. 0. Okay.
Hocam,
Yes.
I'm trying to ask that, say that the car goes like this, and after that, there's some time, we brake, and the box goes like this, right? Because the car goes like
X double dot is not the acceleration of the box.
It's acceleration of, I think,
this. But acceleration of the car or acceleration of the
Acceleration
car?
of both the box and the thing, right? And the car.
I understand your question as well that the whole object is sitting on the truck, but you have to understand what I'm saying.
Mhm.
When you put the foot on the brake, then what we are saying is, yeah, so
The
the
box
whole
moves
object is
to-
the same thing, yeah. The box is also on the truck. So that's why the box and the truck will be subjected to the same acceleration. But when we are writing this question and having a physical feel of it, we are talking about the fact that the driver puts the foot on the brake. So he is putting the deceleration to the truck, and subsequently you will have the same acceleration for the box as well. So when I put the foot on the brake, suddenly the box will be subjected to the same acceleration, deceleration as the truck, that is x double dot, and the box will move. So you put the foot on the brake and the box wants to slide forward, whereas friction wants to keep it
With
towards the left.
deceleration towards the minus x direction.
Below this deceleration, the box will not move.
Good.
It will slide, right?
Good. So for example, if the driver had put the foot very gently on the brake, the box would not have moved. Okay, give me the delta S. Find the delta S. Give me the delta S that truck will move before it stops. Quickly, everyone. Give me the answer.
Final velocity also.
0.
0. Okay.
I'm trying to
That's right. So then here's the hint.
Hocam,
Has to be, I know this.
100% correct, Ebu, your answer is good. Thank you. Good. Excellent. So it's a constant acceleration problem. So I am allowed to use this formula. It's a constant acceleration problem. Delta S is 64.4 meter. You asked a question?
yeah, yes, I need to draw. Hocam. I need to draw. So firstly, it starts with goes with 7 kilometers per hour.
Ah.
And also box also goes with 7 kilometers per hour because there is no force. After some time, when the driver brake, when he pushed the brake, there will be 7 kilometers per hour for the box. Right? The box will be goes like, but the car will be through it. So there will be a friction force. So the box will firstly go with 7, yeah. At that instant, it will go kilometers per hour, 7 kilometers per hour. But with at that instant, there's a deceleration force, minus acceleration, right? And after some time, the box will be stopped at some place we don't know, we will find.
Yes, no, we are not finding it. We are finding the delta is for the whole truck. Yeah. Okay. Okay, everyone. I think that's pretty much it. Should we start work energy right now? We can. Really?
Unfortunately, we're not.
He already said. Any specific thing that you want to discuss? I think huh?
Strength examining.
we will see. About dynamics. Any question?
Concerning dynamics, we can use phase diagrams to express motions, right?
Phase portrait diagrams. I know.
We use them.
Oh yeah, phase portrait. But that is just way beyond our current course. Phase portrait diagram. So if you have a differential equation of motion, let's say for a simple pendulum. Okay. So I think our class is over. I am answering his question. So what we do is in phase, yeah, the class is over. I'm just answering his question. If anyone wants to leave, they are allowed. So what we do is in phase portrait diagram, we make state space. Now, there is a certain process that we follow. We find the eigenvalues and eigenvectors. But I think I need to skip that. I will just tell you the results. So in phase portrait diagram, you will find that a simple pendulum, if this is the rigid rod and there is this bob, then there are actually infinite equilibrium points. One is 0, 0. I'm skipping the details. Minus pi 0, nice. One is pi 0, but then it continues, right? 2 pi 0, minus 2 pi 0, because the pendulum can keep on taking circles. And its phase portrait diagram comes out to be something like this. I'm skipping the details. For an ideal pendulum, by the way, I need to be clear here. There is a question that I'm addressing if anyone is watching the recording. Okay, and we will have a saddle here for a simple pendulum. On the x-axis, you have theta. On the y-axis, you have theta dot. So if you will connect it. So this is what is known as a phase portrait diagram. And again, there will be circle here. And in this way, this can continue. So what is the physical interpretation of this? You take the bob, you take it a little here, 10, 10, 10, 10, 10, 10, 10 for the rest of its life. Then you give it a higher initial condition, 10, 10, 10, 10 for the rest of its life. But if you take it to 180 degree, then you leave it, then it will take these huge circles, right? 10, 10 for the rest of its life. So let's say you remain within this, but you take the bob here, 180 degree, right? And then you give it a push. Then what will happen is that the bob will keep on taking circles for the rest of its life. So you take the bob here, you give it an initial condition, a push, then this is what happens. 10, 10, 10 for the rest of its life. It will keep on taking circles.
Like creating waves.
Yeah, it will keep on taking 10, 10. So this is what is known as this equilibrium point is what is known as saddle. This is known as CENTRE, center. This equilibrium point. I'm not sure why we are even discussing this here. The class is over. This is way beyond advanced stuff, by the way. This is not our. Yes, we can have also office hours. Oh, what is your question? This one? No, ek minute.
Also this one.
So we have 2A delta S equal to Vf square minus Vi square. The velocity is 70 kilometers per hour. 70 into 1000 over 3600 square. Because the 1 hour has 3600 seconds. Then this is a constant acceleration problem, so I am allowed to use this formula. So 2 multiplied by CU. A multiplied CU 64.4. This is how we get it. Okay.
Understand. 3,600.
Okay. So the truck will move 64 meter before it stops because the driver has put a acceleration of deceleration of whatever that value was 2.94, and the driver is doing it because he knows that if he puts too much acceleration, deceleration by putting too much brake, then surely he can stop in 30 or 40 meters, but that instrument package will move and he doesn't want that. Yes.
I have a question. The truck will move before it stops. Why we say that the acceleration
Of this package
acceleration of the truck
and the
will
package.
equals to the
Yeah,
package
because
acceleration.
we are
Why?
saying that that package is sitting on the truck. So when you put the brake, the whole object, the truck as well as the package is subjected to the same acceleration.
Even driver.
Huh?
Even driver.
What we do?
Yeah, even the driver.
You know,
That's a
but-
good one. Huh?
The forces are different, as I think.
Yeah, of course, because their masses are different.
And also their masses are different. So
The acceleration is the same. Because just imagine it like this, right? I'm sitting inside the car as he rightly pointed out. If suddenly I put the brake, I will go forward. So
because my initially I have a velocity.
initially I was a part of the car, but when I
Part of
put
the
the
car,
brake, I'm on my own, unless I have a seat belt. Right.
So acceleration of car and me will be same.
Yeah, in that instant. But when I hit the God forbid, hit the front side of the car, then I'm on my own actually. I'm flying inside the car.
Okay.
I'm no more a part of. Huh?
Or out of the front.
Right. Anyways, thank you. If
Thank
you
you so
don't.
much, Hussein. Very nice.
I have one more question.
Yes,
In
please.
the first physics question, I guess.
Huh? Which one? Zoom out.
Yeah, it's that one, I guess.
This one.
No,
Wait a minute.
after the relative motions. One, two,
The one with the collar.
no. Before that one.
This one. The one with the box.
The one with the friction, I guess.
Yeah, wala, this
I think
one.
This one, yeah. Where did we use the 6 kilogram on this question? Did we use it?
Oh yeah.
Or the
Here.
minus. Oh, the mg.
69.81.
Okay, okay. I think I missed it.
No worries.
Thank you.
Okay, yeah. Welcome.
I'm going to share the midterm on grades.
Dynamics.
Mhm.
It will be after Eid actually. During the Eid vacation, I will grade all the exam papers because, you know, during a regular day, so much is happening that I don't have time to just sit in my office and do so. Eid vacation I have put for grading exam papers. Okay. See
Thank
you.
you.
Bye bye.
See you.